According to Plato, music is the essence of order, and elevates all souls to the good, the just, and the beautiful. In this series of videos on music theory, we will use what we will call the clock analogy to try to explore order and symmetry in music theory concepts such as intervals, scales, and chords. It is hoped that the small sample of the usefulness of this analogy given in this video will motivate you to make extensive use of this analogy in your musical studies. The explanations in the examples given in this video are brief. When applying this analogy in the videos dedicated to particular concepts, they will be more detailed. This video presentation of the clock analogy is divided into two parts. In this first part, procedures are developed that will be applied to the instrument shown on the right in the second part. A remarkable example of order and symmetry in music is the diagram shown to the right of the clock face, which is the result of the search for musical notes following an order of fifths that we performed in two of the previous videos. We have a regular 12-pointed star, so there are 6 axes of symmetry. Note that each of the notes corresponds to one of the hours on the clock face. This relationship, which will remain invariant in our studies of music theory, is the basis of the clock analogy. Next, we show the diagram for the pentatonic notes located on the periphery of a circle as presented in the first video on the generation of musical notes. This is a regular 5-pointed star, therefore it has 5 axes of symmetry. However, the location of the notes does not correspond exactly to the one they have on the clock face, since they were arbitrarily placed equally spaced. Let's generate again these notes, but now on the clock face using intervals of fifths, which corresponds to 7-hour advances. If the notes thus obtained are joined, a star that is not regular is obtained. However, this star has symmetry around the axis passing through the notes G sharp and D. You may have noticed that the natural notes, those without accidentals, are colored on the clock face. These notes together constitute the C major scale, the best known musical scale in Western culture and one that we have all hummed at one time or another. The major scales are the most important from a theoretical point of view, so in other videos we will spend considerable time studying them. The notes of the C major scale were obtained in the process of generating the 12 notes of the chromatic scale by means of a sequence of fifths in the second video dedicated to the generation of musical notes. Here, we will study its symmetry on the clock face. For this we will enclose each of its notes in a circle and we will join them by means of a directed trajectory, as we did with the pentatonic scale. The result is the following. Again, a non-regular star is obtained, but it has symmetry with respect to the same axis corresponding to the pentatonic scale, the straight line passing through the notes G sharp and D. A very important concept in the theory is the degree of a scale. We will use the C major scale to introduce this concept. Next, we will indicate on the periphery of the clock the standard representation in Roman numerals for each of the degrees corresponding to the notes of this scale. Note that these Roman numerals indicate the number of the note within the major scale, with the numbering starting on the tonic note, in this case the C note. Thus, for example, the note G is the 5th note of the major scale and therefore V is used to indicate its degree. This numbering of the degrees is used as a basis for the nomenclature of intervals. Thus, the interval from C to G is called a fifth. In another video we will study the precise nomenclature used for intervals. For now we will limit ourselves to present the intervals from the tonic note C of the first degree to the notes of each of the following degrees of the C major scale, starting with the second degree. However, it is important to note that if the same note is played twice, an interval is produced which is called a unison, and that the interval between two contiguous notes is called a first, or semitone. It is produced by plucking the same string on adjacent frets. Let's start our presentation of intervals. Major second interval. It corresponds to 2 semitones, which constitutes a tone, to 2 hours on the clock face, and to 2 frets on a fretboard. Major third interval. It corresponds to 4 semitones, to 4 hours on the clock face, and to 4 frets on a fretboard. This interval, in conjunction with the major sixth interval and the major seventh interval, determine the major nature of this scale. When we look at the natural minor scale later, we will see that in this scale these 3 intervals will have a shorter extension in 1 semitone. Perfect fourth interval. It corresponds to 5 semitones, 5 hours on the clock face, and 5 frets on a fretboard. The fourth interval receives the denomination of perfect since it is a fifth interval in the descending direction. Both receive this denomination. Perfect fifth interval. It corresponds to 7 semitones, 7 hours on the clock face, and 7 frets on a fretboard. Remember that in the note generation experiment this interval was just what we needed to complete the search. Major sixth interval. It corresponds to 9 semitones, 9 hours on the clock face, and 9 frets on a fretboard. Major seventh interval. It corresponds to 11 semitones, 11 hours on the clock face, and 11 frets on a fretboard. Perfect octave interval. It corresponds to 12 semitones, 12 hours on the clock face, and 12 frets on a fretboard. It leads to the same starting note, but with twice its frequency. It is difficult to distinguish between the 2 notes when they are played simultaneously. Let us now consider the D major scale. The figure shows the data for this scale. We could have placed the note D at the 0 hour, but in developing the clock analogy we decided to keep the locations of the notes, which facilitates the application of this analogy, therefore the degrees appear displaced 2 hours forward. Note that in this scale there are 2 accidentals, in the 3rd and 7th degrees, F sharp and C sharp. In later videos we will study the appearance of accidentals in the different keys. Next we will show how to generate chords. The experiment carried out in the video for the vibrating string revealed that the sound of a pure note, which we will call the tonic, can be enriched by the addition of sounds that have a harmonic relationship with it. A justified choice is the addition of the note that is at an interval of a fifth, at 7 semitones, since in the experiment conducted in the search for musical notes it was found that it leads to a harmonious sound. We have 2 possibilities to add an intermediate note between these 2 notes: the note that is at an interval of 4 semitones from the tonic, major third interval, in which case we have a major chord, or add the note that is 3 semitones from the tonic, minor third interval, in which case we obtain a minor chord. Apart from these major and minor chords, there is a very wide variety of chords, so we will dedicate several videos to their study. However, since the purpose of this video is limited to show how the analogy of the clock can be very useful in musical studies, we will deal here only with major chords. Suppose we want to perform a simple harmonization in the C major key. A first major chord is generated on the note C that constitutes the tonic, with which it is obtained. This chord contains 3 of the 7 notes of the C major scale, the notes C, E, and G. Let us build another major chord using as tonic the note G, on the dominant degree of the C major scale. This chord adds 2 other notes of the C major scale, the notes B and D. The note B is a semitone away from the note C, so the G major chord inserted within the key of C major creates a certain need to return to the C major chord. Many children's songs can be harmonized with just these 2 chords. To complete the harmonization of all the notes of the C major scale, we must add a third chord that includes the notes F and A. Now, since these notes are separated by an interval of a major third, the necessary chord is the major chord of F. Since these three chords, built on the first, fourth, and fifth degrees, harmonize all the notes of the major scale, they allow the accompaniment of a large number of melodies. This concludes the first part of the presentation of the clock analogy. This analogy allowed a non-formal, but visually rich, introduction to the concepts of intervals, scales, and chords. In other videos, we will study these concepts in a formal way, but it is recommended to come back to this video until they are clearly fixed in your mind. In the next video, we will see the application of this analogy to the study of a musical instrument. Thanks for watching this video. We look forward to seeing you in the second part, in which you will find ideas that will help you become familiar with any fretted stringed instrument.